In this video, what I'm going to do is run through some examples of adding fractions. I'm going to start with simple fractions that we already know how to do. I'm going to approach these a little bit differently, just like I showed you how to simplify fractions using some concrete examples with numbers, and then we're going to expand that idea into algebraic expressions or rational expressions. So first thing that we do is we look at our two fractions, and they are not the same denominators. So if our denominators are not the same, we want to put them in factored form. Again, I'm just doing it like this so I can emphasize what we have to do. We probably can see very quickly that our common denominator is 10 and you can create it. But here's what I'm going to do. I'm going to show you the steps that we need to do with concrete numbers, and I'm going to progress into algebraic expressions. So first thing I'm going to do is I'm going to rewrite the 3 over 10 as 3 over, factoring the 10, it's 2 times 5. Now I've got it completely factored. In a sense, what we want to do is put them in the prime factorizations. Next we're going to do is we're going to look at the denominators. This denominator, 5, is not the same as the denominator of 2 times 5, which we knew from the 5 and 10. But what we want to do now is, if it's in factored form, it's easy to create a common denominator. So the common denominator is going to be all the factors that they have in common plus those they don't have in common. So they have a common factor of 5 in each of them. So if I put a 5 down my common denominator fraction, I'm going to clean that up. 5. On the bottom, and then the one thing that they don't have in common is the 2, so I have to include that as well in the common denominator. So we knew from the beginning that our common denominator is 10, but this is the way that we're going to have to work these algebraic fractions. Factor the denominators, get them in completely factored, then start comparing the things they have in common, which were the 5s, put that down in your denominator. Anything that they didn't have in common is going to have to be represented in it as well. So we don't have to repeat the common things that they have, like the 5 and the 5 twice, only once. Okay, so we know our common denominator is going to be 2 times 5, which is 10, or 2 times 5. So now I'm going to take and examine, here's my common denominator, 2 times 5. What is this denominator, my original denominator, under the 2 missing? Well, it's missing a 2, so what I end up doing is creating an equivalent fraction, multiply the top and the bottom by 2. And that's going to be a 2 times 2. That created the common denominator for this fraction. Then I'm going to look at my second fraction, which is right here. Well, this fraction has the common denominator 2 times 5 already, so I don't have to change or alter this fraction. This one can stay just as it is, so I put plus 3. Finally, what I'm going to do is I'm going to take the 2 times 2 is 4, plus 3 all over your 2 times 5, and this is 7 all over 2 times 5. And this is more or less what we're going to do with these algebraic fractions. Okay, so I put a quick reference guide up there, so if you want to take a look at those as you go through, you can do that. I'm going to show you a second example. First thing I'm going to do is going to get it completely factored. So it's 5 over 12 is 2 times 2 times 3 plus, and 7 over 8 completely factored is 2 times 2 times 2. So the first thing I'm going to do is I'm going to determine what the common denominator is. To determine the common denominator, I look at all the things they have in common. I got 2 and a 2. Every one they have in common I represent once. So there's another 2. And they don't share a last 3, so I need a 3, and I also needed another 2. So the common denominator, if you thought about this without doing the factoring technique, the least common denominator between 8 and 12 should be 24. And if you multiply these two numbers together, you got 24, or these numbers in the denominator, you got 24. Okay, so now what we're going to do is we're going to come back and we're going to work on creating equivalent fractions. This is our common denominator. So I'm looking at this denominator, I'm saying, what is this denominator missing that our least common denominator has? Well, it has a 2, 2, and a 3. This one has a 2, 2, 3, but it also has another 2, so I can multiply the top and the bottom times a 2. To create the common denominator, I had to get another 2 in this denominator, so that's 2 times 5, which is 10, plus, now I got to look at this denominator, which is 2 times 2 times 2. It's missing the 3, so that means I'm going to have to make sure that I multiply this denominator by 3, and then the numerator by 3 to create an equivalent fraction. So that gives us 21. So in the end, what we end up getting is 31 all over our common denominator. I'm just going to leave it 2 times 2 times 2 times 3. And that's basically what we're going to do with these algebraic fractions. So I think I had 2 others, but I'm going to skip to the fourth one. And then the fourth one I want to demonstrate here is what you do if they don't have any common factors. So here's our quick reference guide. Factor denominators. Well, the problem with 3 and 11 is that they're both prime, so I cannot factor 11, I cannot factor 3. So therefore, since they don't factor, what I can do is write my common denominator is 11 times 3. So our common denominator is 33, or in this case 11 times 3 with the representation. So then I'm going to go back and say, what would it take to make this 11 a common denominator with our 11 times 3, which is multiply top and bottom by 3. I have to multiply the 11 by 3 to create the common denominator, but I can't create an equivalent fraction unless I multiply top and bottom. So that's going to be a 3 times a 2. Then the next thing we're going to do is we're going to compare our denominator 3 to our common denominator. Well, this one's missing the 11, so I go take it times 11 to create an equivalent fraction, multiply the top times 11. So that's 1 times 11, so plus 1 times 11. Now we multiply, that's 6 plus 11 over 11 times 3, and this is going to be 17 over 11 times 3, or for whatever reason I wrote it backwards, 3 times 11, and that's our final answer. So I've kind of shown you the outline of the strategy using whole numbers here. Now we're going to look at algebraic fractions. Okay, so the first thing is factor the denominator. In each of these, the denominators are already factored. The x minus 2 and the x minus 2, they do not factor. They don't have a common monomial, and they're not the difference of two perfect squares. The other advantage of this one, they already have a common denominator. These are both the same denominator, so I'm going to write it over a common denominator of just x minus 2. If you already have a common denominator, I don't have to multiply either of these, top or bottom, by any number. All I got to do is take the 2x plus the 3x. So in essence, all I have is a 5x if we collect the like terms all over an x minus 2. So that one is fairly easy because it already had a common denominator. If you have a common denominator, you just simply add the numerators and keep the denominator the same. In example number 6, we finally get to one that has different denominators. So first thing we want to do is see if we have any factoring to do. We don't. A lot of the problems I feed you right away, you don't have to worry about factoring it. It'll already be factored. Determine the least common denominator. So here's where you got to be careful. Remember, the fraction bars are grouping symbols. And what we got to make sure is this number, x plus 2, is the same as the value of x minus 2. Well, that's not the case. An x plus 2 is going to be a bigger number than x minus 2, so we know that they're different. So what we have to do is create a common denominator. Now, there aren't any things that they have in common. X plus 2 and x minus 2 are completely unique. So what we do is we just combine them, just like we did with our 3 and 11. Sorry about that, I was thinking 3 and 11. So what we do is we put our x plus 2 times x minus 2 in the denominator. Remember, when 3 and 11 didn't have any common factors, really the least common denominator was the product of those two denominators. The next thing we do is we create equivalent fractions. So now at this point, I'm looking at the denominator of my first fraction, which is x plus 2. I'm going to compare that x plus 2 to our common denominator, which we said is x plus 2 times x minus 2. In order to create an equivalent fraction, I have to multiply the bottom times x minus 2. And if I multiply the bottom by 2, I have to multiply the top by x minus 2. So in essence, what I've got to do to create an equivalent fraction and get a common denominator is take that 7 times x minus 2. Then I'm going to go to my second fraction, which is here. So I'm going to put plus. Now I'm working on the second fraction, and I'm really just kind of looking at the denominator. How is this x minus 2 different from our common denominator? So in essence, I ask the question, what is this denominator missing that my common denominator has? And what it's missing is the x plus 2. So to create an equivalent fraction, I have to take the top and the bottom of my second fraction times x plus 2. So I've got a plus, then I got to take 4 times x plus 2. So in this one step here that you're looking at, I've created a common denominator and created equivalent fractions all in the same step. So I determined the least common denominator, I wrote equivalent fractions, now I need to multiply or distribute. Since we finally have algebraic expressions, now it's important that we remember our distributing rules. So it's 7x plus, let's write it again, 7x minus 14, plus, now we're going to distribute our positive 4, which is going to be plus 4x plus 8, all over your least common denominator, which is x plus 2, x minus 2. And finally what we do is we collect the like terms out of this expression, and if I add the like terms of this expression, it's going to be 11x minus 6 all over x plus 2, x minus 2. What I'm showing you here is there's no reason for us to take and multiply this denominator out. You may leave them in factored form. Whenever you add and subtract, just as I showed you with the numbers, left it as 2 times 2 times 2 times 3. Leave these as well in factored form. Okay, another example, number 7. factor the denominators. They already are. Determine the least common denominator. Okay, in order to determine the least common denominator, I'm going to compare these two denominators. What things do they have in common? The things that I see that they have in common, and again, remember, fraction bar automatically puts a grouping symbol. So they have an x minus 4 factor that's the same in both. So that's common, so I only have to write it once. But what this one is missing is a factor of x. So my least common denominator is x times x minus 4. So I've determined the common denominator. Now I'm going to write equivalent fractions. This denominator, x times x minus 4, is already the same as our common denominator, so I do not have to alter or change our fraction in this first part at all. So I just leave that simply 9 times x. It's the second fraction that we have to do the work on because this fraction didn't have the common denominator. The x minus 4 was in common, but what we need is another factor of x. So I got to take it times x to get a common denominator. So then I multiply the top times x as well. So I got plus 3 times x times x. I can write it out that way. Or what we have is 9x plus 3x squared all over x times x minus 4. Since these are not like terms in the numerator, this is our final answer. Those aren't like terms. Our final answer looks like this. Leave your denominator in factored form. Okay, so still just trying to give you some more depth and change in what we're going to be doing. Here's our next example. First thing we're going to do is see if they're completely factored, and our denominators are still been factored. We're going to determine the least common denominator. Well, they have an x that's in common, so I only have to write that down once. But then I'm missing the x plus 5, so I need an x plus 5 in the common denominator. I'm going to come back and I'm going to write equivalent fractions. Now it's a comparison. Take your first fraction and look at the denominator. What is this denominator missing that our least common denominator has? And that is, it's missing the x plus 5. So now we've got to generate or create an equivalent fraction by multiplying the top and the bottom of this fraction times x plus 5. I don't need that derived program open. Okay, let's close it. And if I multiply the bottom by x plus 5 and multiply the top by x plus 5. It's really important to start thinking about these fraction bars being grouping symbols now, because now you got a binomial times a binomial. So what we have to do is we have to take an x plus 5 times what was already in the numerator, which was 3x minus 1, and we're going to have to distribute that. Okay, so now I hit a plus sign, and now we're going to go to our second fraction. Well, our second fraction, if we look at the denominators, this denominator already matches our least common denominator, so I can leave that one unchanged, so it's just 6x plus 7. Okay, so now what we have to do is we have to multiply or distribute. We're at this stage. We're going to distribute our two binomials, so we'll use FOIL. Our first terms are 3x squared. Our outermost terms are minus x. The innermost terms are plus 15x. And the last terms are minus 5. Then we have our plus 6x plus 7. So I distributed and I multiplied those numbers together. Now what we want to do is we want to collect our like terms in the numerator. So there aren't any other x squared, so all we have is a 3x squared. We have a negative x, positive 15x, and a positive 6x. So we've got 21 of them minus 1, which would be 20x. And then we want to collect our constants, which is going to be 7 minus 5, which is 2. So plus 2. I could write that a little bit better, I think. So plus 2. All over your least common denominator of x times x plus 5. Okay, so right now we're just kind of getting our feet wet. We're starting to see some of the diversity of it. We're going to skip number 9 because it didn't get in there quite the way I wanted it, so we're going to go to 10. Okay, so number 10, what we want to make sure is that our denominators are already completely factored. And in this example, they already are factored, so we get that taken care of. Our x minus 7 and x plus 2 and x plus 2 and x minus 5 are already completely factored. So our first thing is to determine our least common denominator. So I've got to go through and look at my two denominators and see if they have anything in common. And what they have in common is an x plus 2. So I have to write that down just once. So I've taken care of those. But the other two that didn't get matched up also have to be written down in our common denominator, x minus 7. And we also need the x minus 5. This is our least common denominator. So now what we have to do is we have to come back and we have to make some comparisons. look at your first fraction and figure out what is this denominator missing that your least common denominator had for a factor. And what it was missing was the x minus 5, which means on the top and the bottom you have to multiply it times x minus 5. So we've got to take the 6x, and since it's a monomial, I'm going to put it in front, 6x times our x minus 5 to create that common denominator in equivalent fraction. Then I'm going to go to the second fraction that I'm adding. I'm going to look and compare its common denominator, or its denominator with the common denominator, which, what is it missing? So I've got the x plus 2, x minus 5. It's missing the x minus 7. So I have to multiply the top and bottom by x minus 7 to create an equivalent fraction. Now keep in mind, fraction bar means grouping symbol. So that means I have to take and add on to it our addition symbol, 8x plus 1, which was grouped by the fraction bar, times x minus 7. So now what we've done in this little stage right here, we've created equivalent fractions with a common denominator. And now what I'm going to show you is distributing. Because now we got to take and multiply or distribute in the numerator. So we got a 6x times x, which is 6x squared. We have a 6x times a negative 5, which is a negative 30x. Then we got plus. Now we got to do our FOIL on this. So 8x times x is 8x squared. 8x times a negative 7 is a negative 56x. Then the innermost is plus another x. And our last is going to be minus 7. Okay, once we get the common denominator established, once this denominator is established, you don't have to mess with it again, just leave it. The only thing left to do is to take your numerator, which is this beast right here, and start collecting all the things they have in common. So I'm going to write that below here. We got a 6x squared and a 8x squared, which is 14x squared. We have a negative 30x, a negative 56x, and then a positive x. So I'm going to take the negative 30 and the negative 56. That's a negative 86x plus 1 should be a negative 85x. Then our only constant that we have is minus 7. You write it over your common denominator, which was x plus 2, x minus 7, x minus 5. Okay? So you can see they get a little bit longer, a little bit more complex, but you can kind of break down the steps and do exactly what we were doing before. Okay, I think maybe since number 11 is the same as number 10, we'll jump down here and look at number 12. Okay, now this is the first true example where you're going to have to make sure that you remember all of the steps on your quick reference for adding fractions. The first thing we want to do is we want to factor our denominators. This is the first one with algebraic fractions that are not already factored. So we're going to take it and we're going to go through our factoring decision making. So first thing, is there a monomial factor? Well, in this problem, there is a monomial factor, and x comes out of an x squared and a 6x. So we're going to factor an x times x minus 6. Then plus, I'm going to take the denominator of the second one, examine it, does x squared minus 36 factor? There's no monomial factors. It's a binomial, and it's a difference of two perfect squares, so it factors into x plus 6, x minus 6. Okay, so now we have the denominators completely factored. Now we're going to determine the least common denominator. So now what we're going to do is we're going to try to find the things they have in common. The x minus 6, the x minus 6. So you only have to represent that once. But we still have an x that we have to account for, so an x. And we also have another x plus 6 we have to account for. So there's our least common denominator. Go back and take a look at your original fractions and their denominators and compare them to your least common denominator. So we have an x and an x minus 6. So they're already in common with this. What it's missing is the x plus 6. So in essence, we have to take the top and bottom times x plus 6, x plus 6. So it's going to be a 5 times x plus 6, then plus, then we got 9x, and now I'm getting ready to figure out what I have to multiply the 9x times. So here's the original fraction with our common denominator. It is x plus 6 times x minus 6, so I'm looking at an x minus 6, x plus 6. They're in common with here and here. The only thing that this denominator doesn't have is the x. So I got to multiply it times x on top and bottom. So it's going to be 9x times x, and I'm just going to go ahead and make that a 9x times x over here. Okay, to finish it off, we just wrote equivalent fractions. We got to multiply and distribute at this point. So what we're going to do is we're going to distribute the 5, so that's 5x plus 30. Then plus, we're going to multiply those together, that's just 9x squared. And at this point, there's not a whole lot more to do to it other than just a little bit of organization. We want to put it in standard form. So to get it in standard form, what I've got to be able to do is put the 9x squared first, plus 5x, plus 30. There are no like terms, and just write it over your common denominator. X times x minus 6, x plus 6. Okay. I got one final one here that we're going to take a look at, and then depending on your needs, you can refer back to this as often as you need to, or see if there's one that matches one that you're struggling with on your worksheet. All right, so in this one, first thing I'm going to do is I'm going to make sure that this denominator gets put in factored form. So automatically, I look for a monomial. There is no monomial factor, so then we go into two binomials. It's got to be x times x. Signs have to be the same. They both have to be positive, so plus and plus. Now I got to be thinking of factors of 18. Two numbers that multiply together give me 18, that add together to get 11, which would be 9 and 2. Then I'm going to look at the second denominator, which is the x squared minus 81, and I'm going to put it in factored form. Well, this is the difference of two squares, so it's going to be x plus 9, x minus 9. So I've got the denominators completely factored. I'm really not concerned that this numerator is not factored. I'm not even going to touch that. So what we want to do is we want to factor the denominators, leave the numerators alone. That's really not that important for establishing our common denominator. So the next thing we're going to do is we will establish what that common denominator is. So we're on step 2. Find the things they have in common, write it down once. So the x plus 9s go down there once. We have an x plus 2 that needs to be represented. And we also have an x minus 9 that has to be represented. So we represent each factor once, and anything that's in common only gets written down once. Now we're going to go back through and make our equivalent fractions. So now we're examining our first fraction. It's got an x plus 2, x plus 9. What it's missing is the x minus 9. So take the top and bottom of this times x minus 9. And that creates our common denominator that we needed. So in essence, what I got to do is I got to take x minus 9 times 3x squared minus 4x. Always keep it in mind, a fraction bar is a grouping symbol, so I've got that x minus 2 in grouping up there as well. Next thing, take the second fraction and determine what does it not have that our common denominator has. So we got x plus 9, x minus 9. What we're missing is the x plus 2. So I got to take the top and bottom of this times x plus 2. X plus 2. So what I have to do is take this and go plus with our addition sign, and x minus 2 times x plus 2. Okay, now we're at the multiply or distribute stage. So we're going to distribute using our FOIL. That's going to give me 3x cubed. Our outermost minus 4x squared. Our innermost minus 27x squared. And our last is plus 36x. Now plus, I also have to distribute the FOIL on these, on our second terms, which is going to be an x squared. It's going to be plus 2x. On the innermost is minus 2x. And on the last is minus 4. All over your least common denominator of x plus 9, x plus 2, and x minus 9. All that's left is to collect our like terms and rewrite our fraction in standard form. So there aren't any other x cubed, so we got a 3x cubed, but we do have to gather our squares. We have a negative 4x squared, a negative 27x squared, and then another plus x squared. So that's a negative 31x squared plus 1 is going to be a negative 30x squared. And now we're going to collect our x terms. Well, this plus 2x minus 2x, they cancel. So all we're left with is plus 36x. And then we have a constant minus 4 all over x plus 9, x plus 2, and x minus 9. Okay, what I tried to do in as short a time as possible on this video was give you as many examples of the types of fractions that you're going to have to be simplifying and adding. So take a look at it, review it, see if you have some questions. If you do, we'll come back and hopefully address any questions you have on it on adding fractions.